I'm going to go through my storm chase forecasting. This is from the weather site weather.cod.edu, College of DuPage in Illinois, using the GFS model, global forecasting system or something like that. And right here's temperature, lines of temperature, or well, not lines of temperature. Temperatures are color coded with isobars, lines of equal pressure. So this shows you where the low pressure centers are, high pressure centers, and it shows, I think it's a surface. Yeah, basically the surface winds, the 10-meter winds and knots. And so we're looking for area of low pressure, south to southeast winds, which are indicative of that rotating supercells. It usually helps foster rotation when you have south-southeast winds, and then southwest to west winds above that. And so we were going step by step. This would be the first thing. A week or two out. It's like if the temperatures are warm enough. Normally I chase on the East Coast, chase as far as Michigan, Ohio, Kentucky, North Carolina, but mostly generally the northeast region. So when the temperatures are warm, generally the humidity is warm, especially out in front of a cold front and low pressure system. So generally there's enough moisture. Here's a GFS again for the same time period. This shows a supercell composite, chances of rotating thunderstorms. Usually on the GFS I look for yellows or oranges to reds. On the NAM, North American model, I usually look for orange at least. So my view is that the GFS underdoes supercell composite, and the NAM, the GFS underdoes it, yes, and the NAM overdoes it. So you have to take that into consideration. Some other things you can look at are the 850 and 500 millibar winds. The 850 millibar winds are in the black, and the blue are the 500 millibar winds. So if you have a south wind and then stronger southwest wind in the upper middle of the atmosphere, that fosters rotating supercells and updrafts. So again, this is the first thing I look at. Temperature, low pressure areas, supercell composite. I'm not going to look at that. Okay, then we go to the Storm Prediction Center. Let's look at that. And this is day 1, 2, 3, and 4 to 8. So it'd be the next thing I'd look at. And then if I can get a Torcon from weather.cod, because I have very good experts, like Dr. Greg Forbes, and let's see, who else is there? There's another guy I really like, who apparently likes supercell composite. He placed me in New York, a specific area. He pointed to that. Possibly he was looking at a tornado potentially, and I did see a funnel in there. Was a confirmed tornado just a little bit later after that. Okay, so I can look at what Reed Timmer, some other experts might say about the forecast next couple days or next day out. And then what else do I look at? I might switch to the HER, shorter range. See what the forecast radar is showing to make sure that there's precipitation that's going to occur in the environment, and to see what type of mode, if it's going to be supercellular or not. It's going to form a line, or the cells are going to stay a little bit more distinct. And I also look at the updraft heliosities, swaths. So this would show strength of thunderstorm updrafts, and that's where you normally have tornadoes form. There's not really too much severe weather forecast. This is showing some thunderstorms, maybe strong. Mississippi, Alabama. This only goes out like 18 or 24 hours, something like that. Let me see. I guess if you get the 0Z outlook, that actually goes to 36 hours out. That just does it, I think, on zeros, maybe on 12Z also, because this uses actual soundings, not any like interpolated soundings, forecast soundings, but actual, like, I guess, weather balloon soundings. And 12Z also goes 36 hours out. Okay, now back to nowcasting. The day of, as I show you, the day of, I use the HER for the precipitation, and then the updraft heliosity swaths. Yeah, then I go back to good old supercell composite, looking for a 4 or higher. 4 is like minimal. You start seeing the 8s, you get a lot more excited. At least I do, especially in the east or northeast. This isn't showing anything, but I'm just 0 to 3 kilometer effective heliosity index. That can be help you a lot in tornado forecasting also, as it is a composite number. Takes in different variables, and normally I would look for like 2 or higher, or yeah, about 2 is pretty good, maybe 1 minimal. And then I'd look for the low level lapse rates to be at least like 6.5, but higher is better. Definitely when you get in the like mid 7s, it's probably decent, especially in the east. Then you can look at Cape, ML mixed level. I think it's Cape, convective available potential energy, and normally they say look for 1,000 or more for severe weather. And let's see, there's bulk shear, and numbers you're looking for. I don't know, minimally usually. Well, let's see. Let's talk about east, northeast. You probably want to see 35s or higher, I'm guessing, even though you can get severe weather with 25. And then you can go significant tornado parameter. In the east, you're not going to see a lot of high numbers usually, so I mean, you see a 1, you get very interested in, 2, you might get excited, and that's it.